Here's another example of finding an expected value. Find the expected winnings in a single $1 bet in a game of craps. So the probability of winning the game of craps is 244 divided by 495. We worked that out in the last chapter, and that is approximately 0.4929. Just slightly short of 1/2, and that means in the long run the casino will always come out ahead. Let x be the winnings. The probability mass function of x is, and let's look at these two different scenarios. We'll start out with x equals 1 here. So the way this one works is you place your bet of $1, and if you win at the game of craps, they will give you your bet, the $1 back, and they'll give you another dollar back, which means that your winnings is 1. And that occurs with probability 244 over 495. Now there's another scenario here, and that's where you lose $1. So you will place your $1 bet, and if you lose the game of craps, they simply keep your $1 bet, and your winnings then is going to be a -1. That occurs with probability 251 over 495. These two numbers, you can see, add to 1, and because they add to 1, this is a legitimate probability mass function. The next step is to find the expected value of x, and that expected value of x will be the expected winnings. So mu is the same as the expected value of x, and that is the sum over script a of x times f of x. Well, script a in this case is the support of the random variable x, and that is going to be -1 and +1. So we begin with -1. We have x, which is -1, times f of -1, and you can see that f of -1 is 251 divided by 495, plus the second value in the support, which is 1. So there is 1 multiplied by f of 1, which is 244 over 495. And you can see you have a common denominator here. This turns out to be -7 over 495, which is approximately -0.01414. So you can expect to lose about 1.4 cents for every $1 bet that you make. Here is a center of gravity interpretation for this problem. This time what we're going to do is draw a probability mass function. Here is our $1 loss, and here is our $1 gain. And I'm going to draw spikes here. The spike I draw at the loss should be just a little tiny bit higher than the probability of a gain. So this height here is 251 over 495, whereas this height over here is 244 over 495. And our expected value, or the balance point, or the center of gravity of this particular distribution is -0.014. 1.4 cents, and I'll draw an arrow in here, is the expected value. Now, one thing you might have noticed about this problem and some in the past is that even though you will either win $1 or lose $1, the expected value is not one of those two mass values. In previous examples, sometimes it has been one of the mass values, like the previous example, and in other situations it's not. But it does not have to necessarily be one of the mass values. Again, discrete distribution, you can expect to lose 1.4 cents when you play the game of craps.